Having differentiated between periodic and non-periodic functions, we are now going to discuss analytical description of periodic functions. On the whiteboard, we have two examples which we are going to start with. In our first example, we have a function of y is equal to t. That is, the dependent variable is y and the independent variable is t. So we have y. We have y is a function of t, or y is a function of time. Between 0 and 4, the value of the function is equal to 3. So we can now say the function of t is equal to 3 between time is equal to 0 and 4. Y is a function of time, but that function of time is equal to 3 between time is equal to 0 and t is equal to 4. The value of the function y, f of t, is equal to 0. Here we have the t-axis. So the value of y here is 0 on the time axis. Therefore you can say the function is equal to 0 between time is equal to 4 seconds and t is equal to 6 seconds. If we continue with our analytical description, between t is equal to 10 seconds, t is equal to 6 seconds and t is equal to 10 seconds, the value of the function again is 3. Between t is equal to 10 seconds and t is equal to 12 seconds, the value of the function is equal to 0. This function is periodic. It has started repeating itself. The first period starts from 0 to 6 seconds, and another period begins and starts from 6 to 12 seconds. Therefore, this function is periodic with 6 seconds. When you are doing analytical description of a function, you only describe one period only, because the other period are just a repetition of the first period. So you finally conclude and say our function f of t is periodic with 6 seconds. If you are using seconds, it could be time in seconds or it could be time in millisecond or any other unit of time if the independent variable is time. We can summarize all this information. We can say function of time is now equal to 3 for t rise between 0 and 4 seconds. The function is equal to 0 for t rise between 4 and 6 seconds. And finally, our function f of t is periodic with 6 seconds. That is the analytical description of our first function. Let us now analyze our second function. Our second function, we can call this one a function, we can call it a waveform, it could be a signal, but mostly we use the term signal in electronics. In math, we usually use the term function or a waveform. Our function here again is function of y is equal to t, or y is a function of t. Let us now do analytical description. If you look between time is equal to 0 and 3, our curve starts from 0 and it rises up to 4. So we will need to, this is a linear curve or is a straight line. So we need to get its equation. Between t is equal to 3 and t is equal to 5, our graph or our curve is straight, and therefore you also need to get its equation. Here we have a positive gradient, here we have a negative gradient. So when you are determining the equations, we will expect the first portion to have a positive gradient and the second portion, this one, to have a negative gradient. We have already discussed how to determine the equation of a straight line. So we will quickly determine the equations of these two portions. If you look at this function, between 0 and 3, between t is equal to 0 and 3 is similar to t is equal to 5 and 8. And between 3, t is equal to 3 and t is equal to 5, it is similar to t is equal to 8 and t is equal to 10. So again, it appears this function is periodic with 5 seconds. After 5 seconds, the function will start repeating itself. Therefore, when we are doing analytical description, we only do description for only one period. We only find the equation of this line and this line only. That will be enough for us to describe the function. So here, this point here origin is 0, 0, 0, 0 at the origin. This is the value of x-axis, or the value of t is 3, the value of y is 4. Can get a gradient. M is equal to change in y or over change in t. Let us take this as our first point. Here y is 4 minus, here y is 0 or over. Here t is 3, here t is equal to 0. We have the gradient is 4 over 3. Look at our straight line, it cuts the y-axis at 0. Therefore, the y-intercept is equal to 0. The equation of a straight line, in this case, is y is equal to L, which is a gradient, t plus c, which is y is equal, the gradient is 4 over 3, t. Y-intercept is equal to 0. Now the gradient, now the equation of this portion, of this line. We now find the equation of this line. The new gradient is m is equal to change in y or over change in time, which is equal to, let us take this one as a first point and this one as a second point. This point is point, the value of time is 5 and the value of y is 0. It's 0.50. Take this as our first as our first point. Value of y is 4 minus here value of y is 0 or over here value of t is 3, here value of t is 5, which gives us 4, 3 minus 5 is negative 2, which gives us a gradient is negative 2. We also need to determine the y-intercept. We can use the first point and we say y is equal to 4, t is equal to 3. And we also know y is equal to mt plus c, which gives us y is 4. Substituting these values in this equation, y is 4 is equal to the value of the gradient we have found it to be 2, negative 2 times the value of t, in this case, t here is 3 times 3 plus now y-intercept. This is 4 is equal to negative 6 plus c. Take this one on the other side. 10 is equal to c. Meaning, this curve will cut the y-axis at a point y is equal to 10. Now, let us write the equation. The equation now is y. We already have the gradient is negative 2t plus 10. Now we can say, analyzing the curve or analyzing the function, we have function of time is equal to, y is equal to function of t is equal to 4 over 3t for t rise between 0 and 3. That is this line. That's how we can describe it. The first line. Y is equal to 4 over 3t. That is between 0 and 3. The second one is this one. Function of t is equal to, the equation is negative 2t plus 10 for each values of t. For t rise between 3 and 5. For t lies between 3 and 5. We also know that this function is periodic with 5. Because after 5, the function starts repeating itself. Function of time is also periodic with t plus 5. Summarizing the information, we say function of time is equal to that, which is f of t is equal to what? 4t all over 3. F of t is equal to 40 over 3 for t rise between 0 and 3. Function of time, f of t is equal to negative 2t plus 10, negative 2t plus 10 for t rise between 3 and 5, and finally the function of time is periodic with 5. So that's how you do the analytical description of a certain function. You only need to do the analytical description for only one period because the rest is repetitive. We're now going to look at a past paper and we try one example. This paper is October-November 2017. October/November 2017. We're not going to do the first part of the question. The rest we are going to finish as we continue with our topic. We are told this question 5b, the charge Q of t on the plates of a capacitor is as shown below. Then the charges, the equation, the waveform for charges shown here. We have the first part of the question, part 1 of the question is determine the analytical description of Q of t. Determine analytical description of Q of t. We are not going to do part 1. Part 2 we can only do it after we have made some progress in this topic. Here, the dependent variable is charge, which varies with respect to time. The independent variable is time. Therefore, you can say charge Q of t the charge Q is a function of time. You can see between 0 and pi, the charge increases gradually. The charge on the plate of a capacitor, the charge on the plate of the capacitor increases gradually between 0 to pi. It increases from 0 coulombs to Q coulombs. Then at pi, the charge suddenly drops from positive Q to negative Q. This shows us that the function for charge has some discontinuity. Well, there is a sudden change in the value of the charge in the plates of the capacitor. It changes suddenly from positive Q to negative Q. Then from pi, this to pi, from pi radians to 2 pi radians, the charge remains fixed at negative Q. Between pi and 2 pi, the charge remains at Q. Then at 2 pi, the charge starts increasing from 0 coulombs to Q. That shows that the curve has started repeating itself. We have already completed a whole period, and therefore we only require to do analytical description from 0 to 2 pi radians. After 2 pi, the curve starts repeating itself. Now we need to get the equation of this curve, of this straight line. This point is 0, 0. Time is 0, charge is 0. Here, T is pi and charge is Q. This point, this one you don't need to worry about it. Let us first of all determine that one. Now we know that we need to get the gradient M. M is change in charge all over change in time. Here the charge is Q. Take this one as your first point, this one as your second. Here the value of the Q axis is Q, capital Q. Here the value of the Q axis is 0 all over. Here the value of T is pi. Here the value of T is 0. So this one will be equal to Q all over pi. The y-intercept is 0, or the q-intercept is 0, because the curve is cutting the Cartesian plane at point 0, 0. We know q of t will now be equal to mt plus c. M is the gradient. Q of t is equal to m, which is q all over pi t. This c is equal to 0. C is equal to 0. C is equal to 0 because the y-intercept is equal to 0. Here, the value of charge is negative q. We can now start doing an analytical description. Q of t is equal to Q of t, not q, t, for t lies between 0 and pi. 0 and pi. The other one, Q of t is equal to, here the value of this straight line is negative q. Negative q for t lies between pi and 2 pi. And 2 pi. And finally, we remember to say that Q of t is periodic with 2 pi. Because a complete period is, a period is completed after 2 pi radians. So you say Q of t is equal to Q of t plus 2 pi. Now let us summarize that information. Q of t is equal to, between 0 and pi radians, Q of t is Q all over pi times t. Q of t is equal to Q all over pi times t for t lies between 0 and pi. The next one, Q of t is equal to negative Q for t lies between pi and 2 pi. And finally, this one only tells us the periodicity. Q of t is periodic with 2 pi. Is periodic with 2 pi. So that's how you would have done that, the analytical description of that function in the exam. Let us look at one more example. In our last example, we are also going to look at a KNEC past paper question. That is October-November 2013. In this question, you are required to determine the Fourier series representation of the charge on the plate of a capacitor. Though you are not told to determine the analytical description of the function, you definitely require to determine the analytical description of the function. Therefore, you are only going to do the analytical description and leave the rest to a later stage. The function you have here, it shows the charge on the plates of a capacitor and it is periodic with time. This axis, the dependent axis is charge, which is a function of time, and the dependent axis is time. When you are doing your analytical description of the function, you should take a range of 2 pi radian, but you can start it at any point. You could take the range from negative 2 pi to 0, which is 2 pi radians. We could take the range from negative pi to pi, which is again 2 pi radians. We could take the range from 0 to 2 pi, which is 2 pi radians. We could also take the range from pi to 3 pi, which is also 2 pi radians. So you have a number of options on the range of description of your function. But it would be convenient for us if we could take the range from negative pi to pi. So here you can say, taking the range from negative pi to pi. But we also took a different range. We determine the Fourier series representation. You don't get the same answer. Now, this point is point here. The value of independent axis is negative pi. Here, the value of dependent axis or Q of t is negative 1. Here, the value of the dependent axis time around this axis is 0, and the value of dependent axis is 1. This point, the value of the independent axis is pi, and the value of dependent axis is 0. This is the same as saying x and y. We usually start the coordinates, we usually give the coordinate by first of all giving the value of the independent axis, which a lot of time is x, and then we give the value of the dependent axis, which a lot of time is y. So we are used to x, y, but in this case it will be q, it will be t, q of t, q of t. So what we need to do is to determine the equation of this straight line and the equation of this straight line. Let us start with this line. You can see this one has a positive gradient. The gradient of the first line is m is equal to change in q of t all over change in t, which is the first thing. Let us consider this one as our first point. The value of q is 1 minus, here the value of q is -1. So it is 1 minus 1 all over. Here the value of time is 0 all over 0 minus, here the value of time is -pi, so it is 0 minus pi. This is 2 all over pi. Remember, the equation of a straight line is given as y is equal to mx plus c. But this time around, our axis here is q of t is equal to m, which is the gradient. This axis is not x, but it is t, plus the intercept on the independent axis. Here, the intercept on the dependent axis, q of t, is at 1. C is equal to 1. The value is 0, 1. So, the equation for q of t is equal to m is q over pi t plus 1. For this curve, for this straight line, the gradient should be negative because it's facing this direction. Let us find the gradient. M should have called this one like 1, or we can also give it another name. 1 like 1 and 2, or any other name. Can give it another name. Now, gradient is m is equal to change of q of t all over change in t, which is equal to this line down. Take this as your first point. 1 minus this is -1 minus 1 all over. Here, t-axis, the value of t-axis is 0, minus, here the value of t-axis is pi. Now, positive 2 all over -pi. same as negative 2 all over pi. Again, this line cuts the dependent axis or Q of t axis at 1. So the Q of t axis is the intercept on Q of t is at 1. The equation of the curve is Q of t is equal to mt plus c, which is Q of t is equal to m is negative 2 all over pi t plus 1. That is the equation of the curve. Now we do it again. We also know that Q of t is periodic with 2 pi. After every 2 pi radian, the function starts repeating itself. You can see here, at this point where we have considered our period to be starting. We are starting by going up, and then we go down to finish one period or one cycle. Then we go up to begin another period or another cycle. So a cycle is starting at this point and ending at this point. Another one will start at this point and end at this point, and so on. So it is periodic with 2 pi radians. 2 pi radians. Now you can bring everything together and summarize. Q of t is equal to Q of t is equal to 2 pi t plus 1 to 2 over pi t plus 1 for which range of t? For t lies between negative pi here, negative pi and 0. From this line, start at negative pi up to 0. For t lies between negative pi to 0. From this point to this point, that is for t between 0 to pi, Q of t is equal to negative 2 over pi t plus 1. That is for time between 0 and pi. Then finally we say Q of t is periodic with 2 pi. So that is the analytical description of that function. In our next video, we will be discussing how to determine the Fourier coefficients so that we can embark on actual work of determining Fourier series representation of various functions.